Hello and welcome back to Higher Maths Differentiation. We're going to have a look at rates of change here. The derivative of a function describes its rate of change. This can be evaluated for specific values by substituting them into the derivative. So when we are differentiating, we are finding the rate of change. Quite often that will be related to a curve where we're finding the rate of change of the curve, which is the gradient of the curve for a given value of x. Or sometimes it might not have that context, like in example 1 here. Given f of x, find the rate of change of f when x equals 3. So to find the rate of change, we differentiate. So power to the front, reduce the power by 1. And find the rate of change of f when x equals 3. So we are finding f dashed of 3. So I'm going to substitute in 3 for x. So it'll be 10 multiplied by 3 to the power 4. So 3 3s are 9, multiplied by 3 again would be multiplied by another 9. So 3 to the power 4 is 81, multiplied by 10 would be 810. Question 2, for 1 over x to the power 2/3, calculate the rate of change of y when x equals 8. So again, we need to differentiate. We need to differentiate y here. So y equals x to the power negative 2/3. Remember, we cannot differentiate a function of x where x is the denominator. So y equals x to the power negative 2/3. Find dy dx, so negative 2/3 to the front, reduce the power by 1. So negative 2/3 minus 3/3 would be negative 5/3. And then after that, because I'm going to substitute in a value of 8, I would never ever substitute straight into here unless I had a calculator. Okay, don't try and evaluate to the negative 5/3 without rewriting it into a suitable format. So the negative 2/3 stays where it is. X to the power negative something would bring it down onto the denominator. X to the 5/3, well, x to the 5 would be the power. The third part of the fractional index, the fractional power there, the 3 on the bottom would tell us it's the cube root. So we'd have negative 2 over 3 multiplied by the cube root of x to the 5, which is what we've got up here. Now take your cube root first, because the cube root of 8 is 2. We still need to raise that to the power 5, so we'll have negative 2 over 3 multiplied by 2 to the 5. So 2 times 2 times 2 times 2 times 2 again is 32. So we've got negative 2 over 3 32s, which is negative 2 over 96. And then simplify that to negative 1/48. Right, notice here, if we evaluate 8 to the power 5, that's going to be a very, very large number, and it'll take you a while to get there. And then you'll be thinking, I don't know the cube root of that very, very large number. So take the cube root first, which is 2, then raise it to the power 5. Right, putting a bit of context to the rate of change. The velocity v of an object is defined as the rate of change of displacement with respect to time. So if we have s, we can differentiate s to get v. So s is displacement, which is distance moved from an original point. V is velocity, which is the speed in a certain direction. Also, acceleration is defined as the rate of change of velocity. So if we have velocity, we can differentiate velocity, and that'll give us acceleration. So we'll go into this more in further calculus near the end of the course, but here's a quick example. A ball is thrown so its displacement s after t seconds is given by s of t equals 12t minus 5t squared. Find its velocity after 2 seconds. So I have displacement. If I differentiate displacement, I get velocity. So by differentiating this, I'll get s dashed of t is 12 minus 10t. So that's the velocity of the ball for any given amount of time. The time we are given is 2 seconds, so it'll be 12 minus 10 twos, which is 12 minus 20, which is minus 8. So the velocity of the ball will be minus 8. So I'm assuming here the ball has been thrown up in the air, and after exactly 2 seconds, it's fallen back down towards the ground at a speed of 8 meters per second. But the units weren't given in the question, so I can't say for definite it would be 8 meters per second. Okay.